Welcome to This Explainer. You know, we constantly hear terms like AI, algorithms, and neural networks just thrown around everywhere. But today, we're cutting through all that noise. We're going straight to the core mechanics of how these systems actually process the world, moving from raw data to, frankly, incredible discoveries.
So think about this for a second. How does YouTube know exactly what you want to watch next? It's pretty wild when you realize that over 70% of what people watch on that platform is driven entirely by its recommendation algorithm. I mean, have you ever fallen down a rabbit hole of videos and the suggestions just keep getting more and more tailored to your weird, specific niche interests? Or think about how Netflix always seems to just nail the perfect movie suggestion for a Friday night. Or how your phone instantly recognizes your face, even in the dark. It's not magic, right? And there definitely isn't a person sitting in a control room tracking your every move. It's this invisible, incredibly powerful technology that's just quietly powering our daily interactions.
Okay, so at its core, machine learning is a branch of artificial intelligence where computers learn from data and improve through experience, completely without needing detailed instructions for every little situation. Let's kind of contrast this with traditional computer programming for a minute. Historically, if you wanted a computer to do something, you had to write exact, rigid, step-by-step instructions. If X happens, then do Y. But the real world? It's just way too messy for rigid rules. You literally can't manually write a line of code for every single way a human face might look in different lighting. So instead of programming every single rule, developers came up with a flexible, pattern-finding approach. They built a system that can actually look at data, find the patterns all by itself, and improve its accuracy over time.
Think about when you first learned to ride a bike, right? Nobody handed you a manual with mathematical formulas on how to balance, and then you just magically rode off into the sunset. No way! You had to get on the bike, you wobbled, you lost your balance, you probably fell off a few times. But with practice, your brain unconsciously gathered data from those physical mistakes, and you improved. You gained confidence. Well, machine learning works exactly the same way. The AI system learns by studying many examples. It takes in data, makes a few wobbles or mistakes, adjusts its internal math, and just gets better through repeated experience.
And that brings us to a really crucial technical term, training. Basically, this is the process of teaching an AI system using data. You can think of this as the machine's version of practicing. Going back to our bicycle analogy, training is the time you spend in the driveway with training wheels, falling down, getting back up. In the machine learning world, if you want an AI to recognize dogs, you don't describe a dog to it. You show it thousands of pictures of dogs. Big dogs, small dogs, different breeds, different colors. Providing all these examples, that whole process is the training phase. It is entirely dependent on the data you feed it.
And the whole goal of all that training, that's prediction. Prediction is using those learned patterns to make decisions or guesses about new, unseen things. To finish up our bike analogy, the prediction phase is when you're finally balancing and riding down the street completely independently. For the AI that we just trained on dog pictures, the prediction phase happens when you hand it a brand new photo of a dog it has literally never seen before, and it successfully identifies it. It used the patterns it learned during training to make a really accurate guess. So training is the practice, prediction is the successful outcome.
So how does this actually build into a chronological journey? It's basically a four-step process. Step 1, collect data. This could be images, text, videos, numbers, whatever. It just needs raw material. Step 2, study patterns. The system scans through all that collected data to identify repeated structures or behaviors. Step 3, learn from examples. This is where the AI compares its correct and incorrect results. It looks at what it got right, what it got wrong, and it adjusts its internal pathways. And finally, step 4, make predictions. Now fully trained, the system can look at brand new information and give us an answer. Collect, study, learn, predict. It's a really elegant, powerful cycle.
Now, where is this four-step cycle actually happening in the real world? Well, everywhere. It is actively transforming our everyday lives. Social media platforms like TikTok and streaming services like Spotify use this exact cycle to predict your interests and totally personalize your feed. In healthcare, doctors are using machine learning to analyze medical scans and detect diseases way earlier than the human eye ever could. In banking, these systems process thousands of transactions a millisecond to flag unusual spending and stop fraud right in its tracks. And of course, self-driving cars use this to recognize roads, spot obstacles, and make real-time navigation decisions.
Let's dive into an incredibly useful everyday example we all know: spam versus normal emails.
Remember those 4 steps we just talked about? Well, if we want an AI to detect spam, first we feed it thousands of regular, normal emails, and then thousands of those highly suspicious messages from a long-lost royal relative asking for a quick wire transfer. That's our data collection. Then, the AI studies the patterns. It might notice, hey, the spam emails frequently contain suspicious links, really urgent language, or strange attachments, whereas the normal emails have a much more natural conversational structure. It learns from these examples, figuring out the statistical differences. That way, the next time an email hits your inbox, it can instantly predict whether it belongs in your main folder or straight into the junk bin.
But there is a massive misconception we absolutely need to clear up right now. AI does not truly understand information. It detects patterns, uses probability, and makes predictions based entirely on data. When the spam filter catches a bad email, it doesn't actually know what a scam is. It has zero concept of money or trickery or honestly even what an email is. It's not thinking like a human being, it's simply relying on mathematical probabilities. It recognizes that a certain combination of words and links has, say, a 99% probability of being classified as spam based on its past data. It's brilliant math and excellent pattern recognition for sure, but it is not human comprehension.
And because it relies entirely on math and patterns, an AI is only ever as good as its training material. Seriously, for a system to work well, it needs 3 specific things: large amounts of data, accurate data, and diverse data. Think about facial recognition. If an AI system studies millions of diverse face images from people all over the world in all lighting conditions, it becomes highly accurate. But if it only studies a small amount of data, or data that totally lacks variety, it's going to make terrible, embarrassing errors when faced with something that wasn't represented in its training. The foundation absolutely must be solid.
This crucial point is perfectly summarized by a famous rule in the AI world: bad data creates bad results. You probably also heard this referred to as garbage in, garbage out. If you train an AI on data that is flawed or inaccurate, the machine's predictions are going to be exactly the same, flawed and inaccurate. If a major retail company trains an inventory prediction AI on faulty historical sales data, the AI will learn those incorrect patterns and order the completely wrong amount of stock, blindly assuming it's following the rules. Flawed data directly causes real-world operational disasters. This is exactly why responsible, careful data collection is absolutely vital.
And that leads us right to the boundaries of the technology. AI cannot think emotionally, it completely lacks human common sense, and it easily misinterprets complex, nuanced situations. Because of this, it constantly requires human monitoring. For example, a music app's algorithm can flawlessly predict that you usually love upbeat pop songs on a Friday afternoon. But if you're having a terrible day and feeling totally heartbroken, the machine doesn't know that. It completely lacks the emotional intelligence to understand your actual human state. It just blindly recommends the upbeat pop song because the mathematical pattern says so. AI is a remarkably powerful tool to assist us, but it definitely does not replace human empathy and context.
Which leaves us with a pretty provocative question. Since machines completely lack common sense and can so easily misinterpret nuance or inherit our human biases, should AI systems ever make critical decisions entirely without us? We've seen how incredible this technology is, how it learns, adapts, and discovers patterns completely invisible to the human eye. But we've also seen its major blind spots. As machine learning continues to evolve and integrate into our healthcare, our banking, and our roads, where exactly do we draw the line? I highly encourage you to look around your daily life today, spot the algorithms at work, and think critically about the data driving them. Keep questioning, keep learning, and I'll catch you next time.